So today we are going to start with alternating current. Okay, so it is nothing but an extended version of electromagnetic induction where we were discussing on the output of a generator. Correct. So we were discussing on methods of generating EMF, right? So we had a discussion on three kinds of methods of generating EMF. One by changing the magnetic field, one by changing the area, the other one is by changing the orientation of the coil. Correct. The output of the orientation of the coil was alternating in nature, and we derived an equation which is going to be E is equal to E naught sine omega t. Remember that? Yes. So this was the output of a alternating current generator. Okay, so that is how the alternating EMF plays a major role. So this is the alternating EMF which was induced when the orientation of the coil changed. So this is going to be the basic component for any kind of generating unit as far now, right? So and except the one which is solar. Okay, anyways, this is going to be the output of any kind of generating stations as for now. Right, so take hydel, take tidal, wind, thermal, right? So all these are going to have the output as E is equal to E naught sin omega t. Why? Because the generator is going to play a role for generating the electricity. Correct. So the generator's output is going to be E is equal to E naught sin omega t. Clear? Right. So now we are going to completely deal in detail about alternating EMF and alternating current. Right? Why it is not alternating EMF and why it is alternating current? Because alternating EMF anyhow we generate, right? We are going to utilize it as current. Yes, correct. So alternating current plays a vital role. So that is why we are considering alternating current as a separate chapter, and we are going to deal detailedly. Clear? Okay. So what was the waveform which was arrived in that case? So it was like this. Correct. So you had omega t here and you had I here. Correct. And this is nothing but I naught. Clear? Right. And the equation for this is I is equal to I naught sine omega t. This is called as alternating current. So basically what is an alternating current? Which has same magnitude and which reverses its magnitude over a period of time. Right? So that is what is called as alternating current. அதாவது ஒரு waveform which has an magnitude of I naught, say for example, okay, if it is going to have the reversal of the same, right, over a period of time, we call them as alternating current. Okay, it is not necessary that it should always be sine. It can be cos, it can be sawtooth, right? So any kind of thing which reverses its direction over a period of time is normally alternating in nature. Okay, alternating na மேலே கீழே போயிட்டு வரதுதான alternating சொல்லுவோம். It is always reversing its direction, right? The same here. Okay, so the same for alternating EMF also. So we normally call this as periodic wave because it is going to depend on time. Okay, but you have another type also. We normally call that as, what is this? DC, which is going to be constant over a period of time. So it is not going to vary with respect to time. So we call them as direct current. And we normally have this output from a battery, right? And also from solar, right? Solar cells. So this is going to be the output where there is no fluctuation at all. Okay, but basically we use this alternating current and EMF in our domestic appliances. All household needs are basically based on this alternating EMF. Is that clear? Right. So now what we are going to deal with is, we are going to find out what is going to be the average current out of this complete one single cycle. Okay. Before that, whenever you have an alternating condition, right, so we have to analyze something called as frequency. Something called as frequency. So frequency is normally given like 1 by time period. 1 by time period. Okay, and you have one more thing called as angular velocity. Angular velocity is nothing but again angular frequency. Okay, so this is normally given like theta by t. You know this. Angular displacement by time is nothing but angular velocity. Correct? Yes. So for one complete cycle, this we normally call them as complete cycle. Why is that so? Because this is 0. this is going to be t by 2 and this is going to be t. This is going to be one complete cycle over a period of 0 to t. This is going to be t by 4. What will be this? 3t by 4. Kalvasi arak mukal 1. Right? Yes? Okay. This is in the case of time period. When you are completely taking it in the case of angles, this is going to be 90 degrees. This is going to be 180 degrees. This is going to be 270 degrees. This is going to be 360 degrees. It is based on sine of angle. Sine 0, 0. Sine 90 is maximum. Sine 180 is again 0. Sine 270 is minus 1. Sine 360 is 0. So 0, 90, 180, 270, 360. So this is going to form a cycle. Correct? Yes. So where you call this as origin, this is 0 degree, 90, 180, 270, 360. This is for first quadrant, second quadrant, third quadrant, fourth quadrant. So what is going to be the entire displacement of this particular cycle? 360 degrees. Yes or no? Correct. So can I take this displacement as 2 pi in radians? 2 into 180 is 360, right? So that is in terms of radians, it is going to be 2 pi divided by total time is nothing but your angular frequency. And this in turn can be replaced as omega is equal to 2 pi f. Because 1 by time period is nothing but frequency, you can directly write it as omega is equal to 2 pi f. So whenever you are considering sine of angle, it should be cyclic. Whenever cyclic comes, it should be angular frequencies. Is that clear? So how you relate the angular frequency with linear frequency? Omega is equal to 2 pi f. If it is given with linear frequency, you can just substitute and find out what is going to be the angular frequency. Is that clear? Right? Okay. So alternating current has reverse like magnitudes over a period of time, which is subjected to frequencies. But direct current doesn't have, because there is no frequency, there is no possibilities of reversing the directions. Okay. Is that clear? Right? So basically what is frequency? Frequent அப்படினா என்ன சொல்லுவோம்? அடிக்கடி. Correct? Yes. So இங்க alternating currentல எவ்வளவு அடிக்கடி you get maximum and minimum. That is what is frequency. Is that clear? Right? But DC does not have that because it's constant. Okay? Right?